Okay, here we go. So what I want you to, I'm not going to go back on everything we did yesterday. Okay? I'm not going to go back on the problems on V1, C1 equals V2, C2 and all of that. I posted problems for this, so you will test that just like I told you. What I want to come back on is this, is the calibration curve or the unknown and what to do, the dilutions, and what to do in order to find what an unknown is. And use the spectrophotometer in order to find what the concentration is, right? So the first thing that you need to do whenever you're doing something like that, like when you want to do an experiment, set up an experiment and find the unknown, the first thing you need to do is a graph. Okay? And on this graph, you have, of course, two axes, right? And what you're doing here, you're measuring the absorbance as a function of the concentration. So as the concentration changes, the absorbance is going to change. And in spectrophotometry, it's not very difficult. As the concentration increases, the absorbance increases as well. Okay? So let's say that we have this concentration here. We will have a higher absorbance. Okay? And wherever these two meet, that gives us a point on the graph right here. Okay? So when you have an unknown, you have a solution and you don't know what the concentration is. Yesterday we were lucky because the unknown has a color and it was green. So visually you could have an idea of what concentration there is when you compare this unknown with diluted solutions that you're making in a tube. Okay? The most challenging thing whenever you're doing this type of graph in order to guess or to calculate what concentration we have in the unknown is to set a series of points, okay? More than two, because of course between 2 points there's always a straight line, okay? More than 3, ideally, in a perfect world, you would have 8, 9, 10 points. When you are in a time crunch lab, right? You're trying to go as fast as you can, but do it the right way. 5, 6 points will be good. The first point that you can use is actually a standard, a 0, a reference, which has nothing in and should have no absorbance, right? That's the one you're using. So that's your first point. You don't even have to make that. You just make it in order to calibrate your instrument. But this should be about that. Okay? This is where it should be. That's your second point here. And that concentration here depends on what you want to do. And it'll be, experience will eventually tell you, oh, I should do this, I should do this, right? Yesterday, we had a very concentrated grain solution. And we had yesterday and the day before, we had a pretty much diluted solution of an unknown, right? We didn't know how much there was in there, right? So here, we want to have something that is significant, but maybe not too concentrated compared with what we see in our unknown. It's very, very green, and the unknown is very, very, diluted. So maybe you don't really want to use this point and have something that's really, really high in concentration. Maybe you want to dilute that highest, the most concentrated point. Maybe you want to dilute it a little bit, right? And get as close as you can. Okay, listen to this, important. As close as you can to your unknown, if you see the color. As close as you can, but over it. Okay? You don't want your unknown to be more concentrated than your most concentrated tube in all of your standards. You get that? That's very important, right? Because we don't want to be out of range. Our unknown should always be found in here, preferably in the middle. preferably in the middle right here. Why is that? Because you'll have several points, data points here, and the more points you have in there on each side, the more precise your line is. And that's in a perfect world. Of course, we are not living in a perfect world. So these points are actually here and there. They're around this trend line there. They're not exactly on the line, but they should be as close as possible. Okay, so your unknown should be around there. How do you know this? Well, you know this if your unknown is colored and you can see it. You can eyeball it with other standards if you want, right? You can choose. You can look at it and create tubes that will be like more concentrated than your unknown, and tubes that are less concentrated than your unknown. Okay? So you're trying to find that spot where your unknown should be. Okay? Sometimes your solutions are not colored. And I should say that most of the time it's not. You'll be measuring some of your solutions like in very near future. You'll be measuring some solutions that have no color because it's measured in UV light. In UV light, of course, well, we don't detect UV light. Okay? Since we don't detect UV light, you need to do something else. You cannot look visually and try to find that spot. So what you would do in that case, okay, very important, can I ask you to close the door? That would be so nice. Thank you. Okay, what we would do in that case when you don't see that, did anybody forbid you to measure your standard before you do the curve? Did I tell you not to do that? No, I did not. You can measure your standard before you make your curve like that or your trend line. You can do that. Okay? So you can measure it, and then after that you produce this graph with concentrations. You add your molecule that you want to measure or your standard solution, and you make your dilutions in accordance to what you are measuring. So say that your absorbance that you measure, like your uncolored unknown, gives you an absorbance of, I'm just giving an example, okay? 0.026. Okay? Well, your standard, after that, your standards, you can dilute them in order to make data points that are higher than this and lower than this, and this one here should fall in this middle part here. Okay? That's how you should do this. That's how you should think about when you're making a graph in order to find the unknown. It's not very difficult to find the unknown once you've done this. So I don't have a, oh yeah, here it is. So when you have your line, so when you have that trend here, with your data points that are sometimes falling right on the line or here, and sometimes, yeah, you have outliers that are, here or something like that. But you're trying to go as close as you can, and your unknown, what you would need to do is this. You would measure the absorbance of your unknown, and that's going to be, according to this graph, that's going to give you exactly concentration. And always remember that this line here has an equation. This, where m is the slope, b is this point here, the origin, which is, again, in the best of worlds, would fall exactly where 0 meets 0. But it doesn't happen like that, right? So you would have a value added to this. That's usually pretty close to 0. Okay? And the trend line, which your calculator or a computer would give you, should be the R, so you can calculate the R. I'm not going to get into this, but just to tell you, the R, which measures how close your points are to this actual trend line here, should be as close as possible to 1. 1 being all the data points on the line. But that never happens, right? So you have something like 0.098 to 0.095 or something like that. If it's not 0.098, 0.98 or 0.95. If you have something like 0.25, well, you know what? What you measured here is not a line. It's something else. So the equation in that case would not apply. This equation here applies when you have a range between, say 0.99 to 0.85, and that's even pushing it. Okay? So that's what I wanted to tell you about a calibration curve and how you can find your unknown. The other thing I need to mention to you, and that's the last thing I'm going to say about this, is that your graph always has, of course, 2 axes. And you have to think which one varies, okay, in accordance to the other, like in relation to the other one. So that's you're going to decide this way which one is X and which one is Y. That's very important. The other thing is that axes always have units. Absorbance does not have units. So you're lucky, right? But concentration here would have units. It could be mole per liters, it could be micrograms per mil, it could be grams per liter, it can be anything. But in any graph that you're going to make for me, either in an exam or in a lab report, I want these clearly labeled, okay? And don't tell me that I never told you it's on video. All right? Okay? So don't tell me, you'll know. All right? And also, there is always a title to any graph. So this is not a title. This is not a title. The title will tell me, well, this is what we did. Calibration curve for green dye. Unknown. Okay? Something like that. Okay? So there you go. So that's my little, talk about the lab yesterday. Okay? So 2 things. Problems, important. V1, C1, V2, C2, easy. But, it can complicate things, and I throw little curves in there, curve balls in there, so you'll see. And that part here. If you have any questions on this, just send me an email. I'll be happy to help you. Ask me a question after class or whatever, okay? But I'll be happy to help you with this. Is that good? Okay?